Okay, today we're going to talk about inverse trig functions. If you remember about inverse functions in general, a function must pass the horizontal line test in order to even have an inverse. So when we're talking about these trig functions, let's start with sine of x. Ask ourselves, can it even have a inverse? Well, let's look at the graph and see if it passes that horizontal line test. And it's quickly apparent that no, it fails the horizontal line test. So, fails the horizontal line test. There can be no inverse function, so wouldn't it be great if we were done? But we're not, so we're going to fix this problem, okay, that it doesn't pass the horizontal line test by restricting the domain. So between here and, say, here, okay, everything in between there does pass the horizontal line test if I only have the green portion of the graph. So let's figure out where that was again. This was 0, pi. This was pi. This was pi over 2. This is minus pi over 2. So I'm going to restrict the domain so that I can have an inverse function. So x has to lie between pi over 2 and a negative pi over 2. And then we can talk about this having an inverse. On this interval, we should note that the sign is always increasing, and the range of the sign is going to be minus 1 to 1. Okay, the values for sine x run between minus 1 and 1. Alright, so what we can do is let's imagine an inverse sine function that we'll call the arcsine. Or we can simply use that inverse notation, y is equal to the inverse of sine of x, just like when we had f negative x. So f negative 1 of x, that was our notation for inverse, right? Inverse function. So we're not talking about reciprocal. I want to make that very clear. Alright, and like we did before, maybe I should have changed colors, but if I'm talking about arcsine, same as the inverse sine, those are the same thing, it's just some people like to call them different things, then all we have to do is switch domain and range, right? So the domain of this inverse will be, you guessed it, from minus 1 to 1, and the range will be from minus pi over 2 to plus pi over 2. So all I've done is interchange my domain and range. So when I go to graph this, I want to kind of keep that in mind. Let's go to a new page, graph this. Alright, so hopefully you have your notes still in front of you. It'll be a little bit simpler for you to see this. When we had the sine, in fact I need to take a look at it real quick. We have this point 0, 0, right? So when I interchange x and y, I still have 0, 0, so that's good. This point was the point minus pi over 2 comma minus 1, right? That's the x and the y values. So I'm going to change those. Here's my negative 1 on the x-axis, and it's going to go all the way to plus 1. That was the domain. On the range side, I had minus pi over 2 to plus pi over 2. So this point that was here is going to reverse itself and be negative 1, negative pi over 2. It's going to be right there. Okay? And I can do the same thing with the other point that used to be here at plus pi over 2. Here we go. Having trouble. Comma 1. And reverse it, and I'm at 1 comma pi over 2. Now, the curvature is such, if you plotted all the points in between, you'd see it. But I'll show you another trick on how to get the curvature right. Okay. The curvature is such that you could imagine, and it's not true. Remember, this is the start, you know, or maybe I should say the stop. Okay, you stop here at this end of the inverse sine. So what I've graphed here is y is equal to arc sine, right? And you stop here, and it goes no further. It does not go on forever and ever like you see a sine wave do. But if it did, then it would, you can imagine it looking like this. And for me, just thinking about that helps me get the curvature right when I'm doing the in-between. Okay? So you do want to make sure you don't do this, though, for real. All right. Let's see here. So one thing I like to do is calculate when I'm doing arc functions. Let's say I want to find there we go. Find the arc sine of -1/2. Now remember, that's asking the same thing as reverse everything to find the angle. We're back to thinking about angles just because it helps us, such that the sine of the angle would equal a -1/2. Okay? So arc sine -1/2 would equal an angle. The answer to an arc sine or an inverse trig function will be like an angle. Okay, so think of finding that angle. Okay, so we're trying to find theta. Well, of course we know we have a unit circle. Sine is 1/2 at pi/6. To be negative, right? So it would be here at pi/6 for the positive 1/2. So the negative 1/2 would be here and here. Okay, so this is 11 pi/6 on our unit circle, and this was 7 pi/6. Now, which one of these is actually in the range of an arc sine? And that's when you throw out the 7 pi/6. It's not in the range. Or you could say it's not in the domain of the sine, that we've restricted this domain, right? We restricted the domain between here and here. This is what we think of as a first quadrant, and this is really the fourth quadrant in here, right? When you go to -pi/2. So we're going to call that -pi/2 here. So if we're talking about negative angles, then 11 pi/6 is the same as -pi/6, right? So we're going to use this because it's in the range of an arc sine, because it's in the domain that we've restricted for the sine. So my answer would be theta is equal to -pi/6. Okay? So that would be the answer for arc sine -1/2. Alright, I know this is a little confusing. We got to go back and forth between sines and arc sines and things like that, but so why don't you go ahead and try to find the inverse sine of √3/2. So you're thinking about what angle, right, would make a sine of that angle be √3/2. And make sure it's in the domain of our restricted sine, okay? So give it a try, I'll be right back. So there you have it. I have the inverse sine √3/2 is going to equal pi/3. Remember, the answer to an inverse sine will be an angle sort of thing, right? You're thinking like it's an angle. So, we have that. If you need to read the explanation, go ahead. Otherwise, I'm going to keep moving on. Alright, let's start thinking about the other inverse trig functions. Start with cosine. And we're just going to do the same thing we did with sine, except we need to do a domain and a range that makes it a one-to-one function so that we can even have that inverse. And the cosine's a little different than sine. It starts high and goes low and then back up. So that's one full period, and even one full period doesn't pass the horizontal line test. Of course, it goes forever and ever, both directions. But we need to restrict this so that we are one-to-one. So let's pick a restriction. Let's say I'm going to start here, let it go all the way down, and then I'll stop here at the bottom of the function. So I am restricting the domain from 0, thanks Will, to pi.
Hey Dad, what's up?
Right, because of course, you know, we start here, the period of a cosine is normally 2 pi, so this middle point here was pi. So if I restrict the domain to 0 to pi, now I can talk about an inverse for the cosine. So let's write that down. For the cosine of x, we're going to restrict domain x less than or equal to pi, less than or equal to 0. And let's talk about the range again. Well, same as cosine really. Minus 1 less than cosine x less than 1. Okay, so we got that. So what happens is we go to the arc cosine or the inverse cosine. We talk about its domain and range. And so you'll need to remember these, okay, and come up with these. They're not hard if you realize, you know, if you remember the rationale why we're doing this. So domain for the arc cosine minus 1 arc cosine to 1, and range between 0. Oh, see, I messed that up. Let me back up. The domain, of course, is referring to x lying between -1 and 1, and the range, the answers to arc cosines, will lie between 0 and pi, because the answer to a domain is like an angle. Alright, so what should we do? We should graph the arc cosine. So let me try graphing this. Be a little easier now that we have the cosine right there looking at us. I have the domain is from -1 to 1. I have the range from 0 to pi. Okay. I'm going to reverse these points. This is 0, 1, so I have 1, 0, right? And at this point right here is pi, comma, -1. So I've got -1, comma, pi as the other endpoint now. In between, I've got this point right here is at pi over 2, right? So instead of pi over 2, comma, 0, I'm 0, comma, pi over 2, so I'm right here on the vertical axis. And then it's a matter of getting the curvature right and pretend that it's going to go on forever and ever in a vertical fashion. So that gives me my curvature that looks like so. So that's the y equal arc cosine x. Good to go. So we're going to try evaluating some arc cosines. Let's go to the next page. And we're going to evaluate an arc cosine, square root 2 over 2. And let's see. What I'll do is imagine I'm trying to find the cosine of what angle is equal to square root 2 over 2. Okay, so that will give me the answer when I can figure out what that theta is. But, you know, I'm pretty good at my unit circle by now, and I remember square root 2 over 2 is when theta is pi over 4, right? So that'll be my answer, because this pi over 4 is in the range for an arc cosine, because the range, remember, was 0 to pi, and this certainly falls in that range, so that's going to be a good answer for me, pi over 4. So I'll let you try one. Why don't you try finding an arc cosine or an inverse cosine of a -1 and see what you get. Okay, so I'm going to get an answer of pi right here. And you can see I started with this statement that I know is true, that the cosine of pi is equal to -1. I remember from my unit circle. And it's just a matter of rearranging those letters, so we're talking about an inverse cosine, switching x and y values. So that gives me a good answer for inverse cosine. Alright, I want to start to find the inverse tangent. Talk about that, and I'll start by graphing the tangent of x to see how to restrict the domain again. So I've got my axes. And the thing I remember about inverse tangent, it's got those asymptotes I need to worry about. So how does this go? If the tangent, let's see what I can remember. The tangent of 0 is equal to 0, just like the sine of 0 is equal to 0, right? Because we all know tangent is sine over cosine. So that's helpful for graphing. So I know I've got this point 0, 0. I know the asymptotes are when cosine theta equals 0, and that happens at minus pi over 2 and plus pi over 2. Okay? So basically I'm going to have those 2 points marked here as asymptotes, and then you just graph the function between them as an always increasing function because we're talking about tangent. Okay? So there's a tangent, there's one period of it, and if I kept going, of course, I'd have this going on, right? Which would fail the the horizontal line test. So let's go ahead and restrict the domain to what we've already just done. So we're going to restrict for tan x, domain will be x has to lie between pi over 2 and negative pi over 2. The range is a little more interesting for a tangent. What's the lowest we can talk about in the range? Negative infinity. And then the highest, of course, is positive infinity. So now when we turn these around for domain and range of inverse tan, right, the domain will be x has to lie between infinity and negative infinity, and the range will be this short period tan inverse lying between pi over 2 and negative pi over 2. So let's see if we can come up with this graph. The domain will be all the way to the left, all the way to the right. The range, though, minus pi over 2 to plus pi over 2. So those are horizontal asymptotes, okay? You can't go past those 2 places. So that makes sense because they had been vertical asymptotes, and remember we're just switching things horizontal, vertical, x's and y's. So now those are horizontal asymptotes rather than vertical asymptotes. I'm still going to have the point 0, 0, and how am I going to think about this? Should I go above, below? Where do I start, right? When I'm looking at the graph of tangent, you know, I've got both the x and the y values are negative at the same time. So when I switch, it's going to be the same thing. They're both negative at the same time. So if I'm at negative x values, then I'm at negative y values as well. So I'm going to come up, come up the asymptote. Oh, don't do that to me. There we go. Cross my 0, 0. And then be in positive territory for my inverse tangent, and it goes on forever and ever in this case. Alright, so that's what the graph looks like. Let's try some problems. Alright, let's find the arctan of -1. So that's going to equal something, looks like an angle to us right now. So I have to say the tangent of what angle is equal to a -1? Well, first of all, the tangent is negative in the second or fourth quadrant. Which one of those fits my restricted domain? Of course, is fourth quadrant, so we'll throw that one away. So we're talking about theta could equal minus pi over 4. Okay? So I'm going to say arc tan of -1 is equal to minus pi over 4. Because remember, I restricted my domain from minus pi over 2 to plus pi over 2. So my answer had to be in that range, okay? And I'm going to say this is true here because I know it's true that tan of negative pi over 4 is equal to -1. Okay, so these two things go together. It's kind of like writing back and forth function, inverse function, switching x's and y's. Remember, one of the ways we defined an inverse function was that it would undo each other. A function and its inverse work to undo the other. And we would write this as f composite f inverse of x would just return a value x. So you start with x, you do the inverse function composite, then you take the function, and you just get right back to x. And the same thing's going to happen with these inverse functions. So you have things like the sine of arc sine x will just equal x if if the domains and ranges allow. Okay, so there's this little caveat here that we have to be really careful with our domains and ranges, okay? So let's take an example of why we can get a fail if we aren't paying attention to domains and ranges. And say we were asked to find arc sine of the sine 3 pi over 2, okay? Now you're tempted to say the answer to that would be 3 pi over 2. But will the range of arc sine, so can it equal 3 pi over 2? But wait a minute. The domain of sine, this is how I have to remember it, has been restricted to minus pi to pi over 2. So that means the range of arc sine has been restricted to minus pi over 2 to pi over 2. Okay? Domains and ranges trade places. So this is not in the range of the arc sine. So it cannot be an answer to an arc sine. So here's where we have a fail, and we don't get that. Okay? So let's see what you really do get. Okay? So what you'd have to do in this case is you'd have to figure out what is the sine of 3 pi over 2. Okay? So just kind of do things the old-fashioned way without this kind of, nice inverse function relation. So the sine of 3 pi over 2, if you remember, 3 pi over 2, oh, that's that negative vertical axis, right? So the sine's going to be a -1. Okay. So now I'm left to find the arc sine of a -1, making sure I match my domains and ranges. So the answer to this would be, I'm going to call that angle so that it matches up with this. Remember, I have to pick an answer that's in here, so I'll just call it minus pi over 2. So that's my answer. Of course, you see how it's very different from what we'd started with. I mean, it's the same angle, but it's a different value, okay? So this is where we're getting away from angles, and we're talking about just x values. Those are two very different x values, even though in our minds they're talking about the same angle, but they are different. Alright, I know this is really kind of confusing. It just takes a lot of practice with domain and ranges. And having, for a while you might want to have them written down what those domains and ranges have to be, okay? But go ahead and try this one. Finding the tangent of the arctan of a -5. You can check your domains and ranges, and if everything's okay, it's an easy question. If not, do it the hard way. Alright, so this one, if you were careful, you get the same answer as if you weren't careful. So if you weren't careful, you're just going to call it a -5 and hope for the best. And in fact, that's correct, because a -5 is indeed in the domain of an arctangent, because the domain was all the way from -infinity to infinity. Okay? So, you know, we've got that. We can find what the arctan of that is, and then we can take the tangent of that. It won't, the only thing you can't take the tangent of are those, you know, the vertical asymptotes, and we're not there, because then it wouldn't have been in the domain. So okay, let me try that again. I might have misspoke if you caught that. We're just going to leave it, -5 is in the domain, therefore there's no problem, and just go ahead and cancel these out. Okay, and there's your answer right there. So we're going to call it quits because this is getting long already, and we'll finish up when we have to do composites by constructing triangles. So let's make sure we cover that in class.